Hey guys, welcome back to my channel. In this video, you will learn to work with binary search algorithm. That is, you can understand what is binary search algorithm, how it works, and how to use this algorithm to perform an optimized search on a sorted data. And finally, I will show you the pseudocode of this algorithm. Now let's see what is binary search algorithm. From the name itself, we can understand it is a kind of searching algorithm. Say for example, we want to search a word in a dictionary. Normally what we will do is we directly go to some approximate page, let's say middle page, and start searching from that page. If the searching word is present in that middle page, then the search is complete. If the searching word is present before the selected page, then apply the same process for the first half. Otherwise, apply the same process to the second half. This binary search algorithm also works in the same way. The main idea of this algorithm is to use divide and conquer method, which means it will continuously divide the array into two halves until a search element is found, so that on each iteration, half the amount of searching space will be reduced. This algorithm works efficiently on sorted data, so we need to sort the array before applying this algorithm. Now let's understand how this algorithm works. For that, let us consider an array where the elements are sorted, and you will be having three iterators, namely left, right and midpoint. Initially, this left iterator point to the starting index of the array and this right iterator point to the ending index of the array. And this midpoint will directly hit the middle element of the array and point to that index. This midpoint will be calculated by taking the average of left and right. Now, this middle element will be compared with the search element. If the middle element is equal to the search element, then the algorithm will return that index. If the middle element is greater than the search element, then it means the search element is available on the left side of this midpoint. So, this algorithm will move this right iterator to here, that is mid minus 1. If the middle element is less than the search element, then it means the search element is available on the right side of this midpoint. So, this algorithm will move this left iterator to here, that is mid plus 1. Now, let's see how to use this algorithm. Say for example, this is the given array and the search element is 4. Initially, this left iterator point to the starting index and this right iterator point to the ending index. And this midpoint will be calculated like this. Here 0 is the index pointed by the left iterator and 6 is the index pointed by the right iterator, and the average is 3. So this middle iterator point to the middle index of the array. Now this middle element is compared with the search element. Here 7 is greater than 4. So we need to move this right iterator to here, that is mid minus 1. Here mid is 3 and minus 1, which is 2. So right iterator point to second index of the array. On the second iteration, we need to calculate the new midpoint. So L is 0 and R is 2 and the average is 1. Now this middle iterator point to the first index of the array. And then this middle element is compared with the search element. Here both are equal. So this algorithm will return that index, which is 1. So this is the pseudocode of this binary search algorithm. So this algorithm will works until this left iterator less than or equal to the right iterator. Otherwise, it will return minus 1.